Hello guys, how are you today? So today I'll be solving the CQDs or the course revision questions for the geometry periodic, but I'm only gonna be doing the grid and the suggested questions by, if you open the math material, you will see the recommended questions. So the first grid that we have is grid number 1, which is question number 9. So question 9, grid number 1. They tell us in this question, use the figure to answer the question. They need us to find the area of triangle CPB over the area of triangle PAD. We need to know that this ratio or this fraction, so area 1 over area 2, it's equal to constant squared. So if we are not given the factors to find the area, what we could do instead is take the sides, but because they are not vertical, or they are not like directly proportional triangles, meaning this is not directly proportional to this, instead this is proportional to this, so we have to keep in mind. So they're telling us the area of CPB, you're gonna take the side in CPB, which is 2, over the area of PAD, so you're gonna take the side that is in 5, not in 5, sorry, you're gonna take the side that is in triangle PAD, which is 5. So 2 over 5 is equal to the constant K, which is 2 over 5. And then that means that the ratio of area 1 over area 2 is equal to the constant squared, which is equal to 2 over 5 squared, which is then 4 over 25. We move on to question number 10, grid 1. They told us, given a circle whose circumference is 10 pi, they need us to find the area of the circle. We know that circumference of a circle is 2 pi r. So it's equal to 10 pi. You cancel this and this, you're left with 2r is equal to 10. So then r is equal to 5 centimeters. Now to find the area, we know that the area of a circle is pi r squared. So it's pi times 5 squared, which is then 25 pi. We move on to question number 13. They told us they need us to calculate the shaded region, knowing that the radius of the circle is 10 centimeters. What we need to know is that the area of the shaded region, it is the area of the sphere, not the sphere, of the sector, minus the area of the triangle. So, very simply, to find the area of the sector, it is angle over 360 times pi times r squared, minus the area of a triangle. Of any triangle, it's 1 over 2 times sine the angle times side. So if you're gonna substitute, it's gonna be 90 over 360 times pi times 10 squared minus 1 over 2 times sine 90 times side. So very simply, if you put it on your calculator, so 90 over 360 times pi times 10 squared, you're gonna get 25 pi, okay? And you're gonna subtract it from 1 over 2 times sine 90 times 10, so you're gonna get minus 50. So the area of the shaded region is 25 pi minus 50. Alright, so we will move on to the next grid question, which is actually a top question. Do we have a top question? Let me check. No, we do not have this top question. Question 18 is not required from us. So we will move on to the required questions. So the next required question is question 26. Okay, so very simply in this question, we know that ABCD is a parallelogram. This is 6 centimeters. This is 4 centimeters. This is also 6. This is also 4. They said PQ is an arc of circle and the radius is 2 centimeters. So they told us if AC, we are given that AC is 5.2 centimeters, we need to find the measure of angle ABC. Very simply, to find the measure of angle ABC, we are going to apply the cosine rule. The cosine rule states that it is side squared plus side squared, and these two sides have to be making the angle, minus the opposite side squared, which is minus 5.2 squared, over 2 times 4 times 6. And very simply, you're going to get that cosine of the angle, it is equal to this, which is 5.2 squared over 2 times 4 times 6. You're going to get 13 over 25. So then the angle x, it is shift cosine 13 over 25, which is approximately 58.7 degrees. So we found that this is 58.7 degrees. Now, they need us to find the area in centimeters squared of the shaded region. Very simply, to do that, we're going to find the area of the parallelogram minus the area of the sector. So very simply, we know this is 6, this is 4, and the angle is 58.7 degrees. So to find the area in centimeters squared of the parallelogram, it is 6 times 4 times sine the angle in between them, which is 58.7 degrees. Now, we are going to subtract this from the area of the sector. We know that this is 2 and 2. So the area of any sector, it's angle over 360 times pi times the radius squared. So very simply, if you put it on your calculator, 6 times 4 times sine 58.7 minus 58.7 over 360 times pi times 2 squared, you're going to get an answer which is approximately almost 18.5 centimeter squared. So the area in centimeters squared of the shaded region is almost 18.5 centimeters squared. So this is 58.7 degrees, and this is 18.5 centimeter squared. Now they need us to find the perimeter of the shaded region. So to do that, you're going to add all the sides, including this side over here. So if this is all of it 6 and we're removing 2 from the radius, then you're going to be left with 4. And if this is all of it 4 and you're removing 2 from the radius, then you're going to be left with 2. So we have 4, 2, 6, 4, and we need to find the length. To find the length, very simply, we're going to do angle over 360 times 2 times pi times the radius, which is 2. Okay, so 58.7 over 360 times 2 times pi times 2, you're gonna get it to be approximately 587 over 900 pi. But then we are gonna add it to what? We're gonna add it to 4 plus 4 plus 6 plus 2, and you're gonna get that the perimeter is approximately 18.05 centimeter. Now we'll move on to the next required thing, which is question number 31. T31, here we go. They need us to find what? To find the sector angle x. Very simply, to find the sector angle x, we have to apply a rule that we remember from the AMS. It is either the circumference 1 over circumference 2, or you just do the radius of the smaller circle, which is 4, over the radius of the bigger circle. You consider it as a bigger circle, over 12. 4 over 12, you're going to get an answer of 0.3333. Keep it as it is, okay? You're going to multiply this by 360, and you're going to get that the angle x is 120 degrees. Okay, now to find the area of the shaded region, you need to first find the area of the sector and subtract it from the area of the triangle. Very simply, the area of the sector is angle over 360 times pi times the radius. We know that the radius is 12 times 12 squared. Then you're going to subtract it from the area of the triangle, which is 12 times 12, so side times side, times 1 over 2 times sine the angle in between them, which is 120. So on the calculator, 120 over 360 times pi times 12 squared minus 12 times 12 times 1 over 2 times sine 120, it is very simply going to be 88.4 centimeter squared, very simply. Then we move on to the next recommended thing. Hold on, I just have everything recommended on a paper, which is question number 37. We move to question number 37. This came in the AMS actually. They said, what's the lateral area of a right circular cylinder whose height is whatever? You should know that the lateral area of a cylinder is 2 pi RH. My apologies. So it's 2 times pi times the radius, which is 9, times the height, which is 10 over pi. This goes away with this goes away with this, and you're gonna get your answer, which is 180. This is the lateral area. So we finished question, my bad, I dropped my highlighter, 1 second. We finished question number 37, we move on to question number 42. What is the volume of a regular square pyramid whose height is 15 and the length of a side of its bases is 8? As you can see, these questions came in the AMS quiz, okay? So, you know, a square pyramid has a base of a square. And the volume of a regular shape pyramid, it is 1 over 3 times the area of the base times the height. So it's 1 over 3 times the area of the base, which is 8 times 8, times the height, which is 15. Just put it on your calculator, and you're going to get the answer, which is 320. Now we move on to question number 43. What's the radius of a sphere of this volume? You know that the volume of a sphere is 4 over 3 pi r to the power of 3. So you cancel pi and pi. Then you divide these two by each other, and you're going to get that r to the power of 3 is 5324 over 3 divided by 4 over 3. You put it on the calculator, and you are going to get that r to the power of 3 is 1331, so then r is equal to 11. Very simply, that is our answer. So we finished number 43. We'll move on to 44, because these are recommended from 42 until 44. They need us to find the surface area of a sphere given its volume. You know that the volume of a sphere, it is 4 over 3 pi r to the power of 3. So it is 8788 over 3 divided by 4 over 3. Why? Because we cancel pi and pi. It's equal to r to the power of 3. So r to the power of 3, it is then equal to 2197. So then r is equal to 13. Now that we have the value of r, we need to find the value of k. You know that the surface area of a sphere is 4 pi r. So it is 4 pi r squared. So it's 4 times pi times 13 squared. So it is 676 pi. Okay? So like that, we finished what? We finished questions 42 to 44. Now we move on to question number 50. Find the surface area of a regular tetrahedron with side length being 6 centimeters. This might come in the written part. We don't know. It might come in the written part, but let us just explain what it is. So the surface area of a regular tetrahedron. A tetrahedron, it is a pyramid in some sort, but with a base of a triangle. And we know that a regular tetrahedron is made up of 4 triangles in total. So it has the base triangle, which is 1, and then it has side triangle. I don't know how to draw it. Let me just search it up. So over here, this is a tetrahedron. It's made out of 4 triangles that are literally the same. So you have one triangle over here, another triangle over here. I will do a different color for each. Another triangle over here, and the final triangle is this base over here, which I will do it in green, as you can see. So it's made up of 4 triangles that are exactly the same because it's a regular tetrahedron. But what you should know is that they are looking for the surface area, and surface area is the total area of all sides, as you remember from before. So the total area of all sides, we know that they're all the same triangles. So if you find the area of one triangle, let's just say area of triangle, then it's gonna be the same for all triangles. So very simply, you can do area of the triangle times 4. Okay, so just keep it in mind. For a regular tetrahedron, this is its rule. Okay, and it has side length being 6 centimeters. So when they say that it's a regular tetrahedron with side length 6 centimeters, that means the four triangles are equilateral triangles that are just like in general. So we're gonna take it like this. Just imagine this is the tetrahedron we're talking about. This is 6, 6, and 6 centimeters each. So now the total surface area is gonna be 4 times the area of a triangle. But we know that the area of a triangle, it is base times height over 2. So very simply, let us find the height. This is gonna be 3, 6. You can find this by doing radical 6 squared minus 3 squared, and you're gonna get that the height is gonna be 3 radical 3 centimeters. So now the surface area of a regular tetrahedron, it is very simply 4 times the area of this one triangle, which is the base, 6 times the height, which is 3 radical 3 over 2. Put it on your calculator, you're gonna get an answer of 36 radical 3. So the surface area of a regular tetrahedron with side length 6 centimeters is 36 radical 3. And just like that, we finished question number 50. We move on to question number 58. 58, here we go. They told us, find the volume of a sphere of radius 4 centimeters correct to 3 significant figures. The sphere is placed in a cylindrical container of radius 5 centimeters. Okay, first of all, let's do part A. The volume of a sphere of radius 4 centimeters. You know that the volume of a sphere is 4 over 3 pi r to the power of 3. So it is 4 over 3 times pi times 4 to the power of 3. So it's gonna be correct to 3 significant figures. It's gonna be approximately 268 centimeter cube. This is the volume. Now, the sphere is placed in a cylindrical container of radius 5 centimeter filled with 1 liter of water. They need the new height of the water in the container. We know that 1 liter is 1,000 centimeter cubed, so 1,000 centimeter cubed plus the volume of the sphere, which is 268, you're gonna get 1,268 centimeter cubed. This is now the new volume. Now to find the new height of the water in the container, you're gonna apply the rule for the volume of a cylinder, which is pi r squared h. It is equal to 1268, and we know that the radius is 5. So very simply, 1268 divided by 5 squared times pi, you're gonna be left with the height, which is gonna be approximately 16 centimeters. So we finished question number 58. We will move on to the next question, which is question number 66. 162, 63, 64, 66. Here we go. A solid cylinder has a volume of 180 pi centimeter cubed and a height of 5 centimeters. So, they need us to find the radius of this cylinder. Very simply, to do it, you know that the volume of any cylinder, it is equal to pi r squared h. So you get rid of this, and you know that the height is 5. So now, just divide both sides by 5. You're gonna get that 36 is equal to r squared, so then r is equal to 6. Now we have the radius of the cylinder, which is 6. Okay. We move on to part B. A solid cone with a height of 10 centimeters is attached to a cylinder to make this new solid. You know that the volume of the cylinder at the bottom is 180 pi, so just keep it like this. Now to find the volume of the cone on top, it is 1 over 3 times pi r squared h. We know that the radius is the same because they're on top of each other. So it's going to be 1 over 3 times pi times 5, not 5, we got the radius to be what? To be 6. So times 6 squared times the height, which is 10 centimeters. So you multiply them all together and you are going to get 120 pi. So add these two together to get the total volume, which is going to be 300 pi. This is the new total volume. Now in part C, they said a solid similar to that of part B has a volume of this much. You should remember the ratios, that volume 1 over volume 2 is equal to k cubed, area 1 over area 2 is equal to k squared, and side 1 over side 2 is equal to k. So if you have volume 1, which is 8,100 pi, over volume 2, which is 300 pi. You put them on top of each other, you're gonna get an answer of 27. So k cubed is equal to 27. That means k is equal to 3. Now, side 1, we have the radius of side 1 that we need to find over the radius of side 2, which is 6. It is equal to 3. So you cross multiply and you're gonna get that side 1 or the new radius, it is equal to 18 centimeters. Okay? So we move on to grid 2 questions, which are questions 77 and 79. So, 77, here we go. These questions might come, pay attention. In the given figure, the area of rectangle ABCD is 18 square units, and P and Q are the midpoints of the bases BC and DA, respectively. The area of parallelogram BP DQ is x square units. What is the value of x? Very simply, to find the value of x, it's actually way simpler than you think. So, because these are the midpoints, if you draw the line QP, it is also the midpoint. So it's dividing this into half and this into another half. And as you know, that these diagonals are also split. They will also split these two smaller halves into another pair of halves. So very simply, what you could say is that this is 1/4 of the total triangle. Not triangle, of the total rectangle. Okay? So, if the area of the rectangle is 18 square units, they need the area of the parallelogram. So you're going to take the parallelogram. So it's going to be half times the area of the rectangle, which is 18. So you're going to get it to be 9 centimeters. Now, I remember there was a case, someone told me about it. So there was another question that some grade 9 students got in their AMS. They got that the total area was 24 square units. And what they got was, let me just read the question 1 second. The question states that P, B, and Q are midpoints. So over here we have P, the midpoint. Over here we have Q, the midpoint, and B wasn't drawn. So in the figure that I was given, the B was not drawn. So I don't know how it might come. But it was like this. They joined it like this, and QP was joined like this. They told us they need the area of DPQ. Very simply, to find the area of DPQ. So there are very many ways to explain this, okay? Now, one way to take it is that, okay, as you can see, that Q and P are the midpoints. That means if you draw a line like this, you will officially be separating it into 2 equal parts. So if it was 24, then this is now going to be 12, and this is also going to be 12. And also another thing is that if you separate this like this, you will kind of be separating it into 1, 2, 3, 4 congruent triangles. It does not look like 4 congruent triangles, but it is 4 congruent triangles. So what does it mean? That means to find the area of one of these triangles, it's going to be 12/4, which is then 3. Okay, we'll move on to the final question, which is question 79. Here we go. As you can see, this is also something similar to the AMS quiz. So very simply, we know that the volume of one tube, or a singular tube, it is pi r squared h. Pi, because it's a cylinder. So pi times the radius, which we found to be 4, times the, times the radius, which is 1, squared times the height, which is 4. So you put it on the calculator, it is 4 pi. And he said that 85% of its capacity can be filled. So 4 pi times 85%, you're going to get 3.4 pi. Now this is how much can actually be filled versus how much pint he has, or pint, I don't know how you say it. So it's going to be 2 times 2, 28.875. So you are going to get 57.75. So now you're going to divide this by 3.4 pi. After dividing it, you are then going to get approximately 5.4. So what is 5.4? 5 is how much he can fully fill, okay? Whereas like 0.4 is what he has left. So he can fully fill 5 test tubes. So the answer is C. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.